It is the center of our galaxy, and one of the essentials to life on Earth. Is really important. People have been studying the sun for years. It even was the root for many religions, both in real life and in media. What is the sun, though? Well, essentially, the 1,391,684 kilometer wide orb in space is one big chemical reaction. And as stated before, it is one of the, or if not, most important chemical reactions for life on Earth. Now, this reaction isn't any regular type of reaction. The reaction that the sun has been doing constantly for 4.57 billion years is a nuclear reaction. More specifically, a fusion reaction. The sun is made mainly of hydrogen gas. The hydrogen gas is very hot because of the friction caused by the sun's gravity. The hydrogen is so hot, in fact, that the atoms are no longer bound together. The pieces are just floating around, a huge mass of protons and electrons. The sun has a huge mass. It has an enormous gravitational pull as well, so a tremendous amount of pressure is being pushed down on the hydrogen because of these aspects. Now, because of this pressure and the lack of electrons in their orbits, the hydrogen protons get pushed together so closely that they actually fuse. This is the fusion reaction, which leads to the formation of helium-4. Now, you may be asking, how can helium-4 be formed from hydrogens that lack neutrons? This is the beauty of fusion, though. When two protons are forced to fuse together, one of the protons loses a positron and a neutrino and becomes a neutron. This formation causes a loss in mass. This mass becomes energy and is released as light and heat energy. This follows the physics equation proposed by Einstein, E equals mc squared, which states that energy can be changed to mass, and conversely, mass can be changed to energy. So, two protons fuse, and one becomes a neutron, forming deuterium. Another proton is fused to the deuterium, forming helium-3 and releasing photons. This is happening all over the sun, and eventually, two helium-3 atoms fuse. This fusion does not make beryllium, however. Instead, two protons are dispelled with energy, and helium-4 is formed. Each step of this fusion releases energy. The energy released by these reactions slowly makes its way out of the sun, but it's constantly bumping into particles. The particles it bumps into absorb some of the energy, so by the time it reaches the edge of the sun, it is severely less powerful than it was when it started. This energy can now freely make its way throughout space, and eventually, some hits Earth. Earth's atmosphere absorbs a lot of the energy, but some of it does get through. What does this energy do for us, economically and socially, and what does it do for the environment? Gee, I wonder. The energy released from the sun comes in both the form of light and heat. Now, particles of this light energy are called photons, and photons bring light to the world so we can see. Also, in solar panels, photons hit electrons and loosen them from their atom's pull, thus creating a flow of electricity. Plants and other organisms that photosynthesize create sugar and oxygen out of the sun's light. Without them, other organisms wouldn't have food or be able to breathe. The heat energy is immensely useful to the Earth. If there was no heat energy, everything would freeze, and life would cease to exist. Heat also creates many of the Earth's natural effects, such as weather and climate. The sun's energy is extremely great for the Earth, though, in the words of Uncle Ben, rest his soul, with great power comes great responsibility. And no, I'm not talking about making sure you wear sunscreen, though skin cancer isn't fun. The burning of fossil fuels creates carbon dioxide gas, which is fine in small amounts, but at the rate us humans create it now, it clogs up the atmosphere, and all of the sun's heat gets trapped in the Earth. This causes climate change, which can wipe out ecosystems and potentially destroy all of humanity as we know it. Well, there you have it. The sun. A gracious giver of life, or a nuclear explosion just waiting to wreak havoc. Like Bondi with grade point averages. Well, I guess we'll just have to wait and find out. Thanks for watching. Have a beautiful day. Now, this reaction isn't any regular type of reaction. The reaction that the sun has been doing constantly for 4.7 Also, in solar panels, photons hit electrons and free them from their atoms. Also, in solar panels, a photon will hit an electron and free it from its atom's pull, thus creating an electrical charge.